Hello everyone. In the previous videos, we have discussed about what are logic gates, what are their truth tables, and we have discussed about what are multiplexers, and we have discussed about the basic two types of multiplexer. Those are 2 cross 1 and 4 cross 1 multiplexer. In today's video, we are going to discuss about how can we construct logic gates using our known multiplexers. Like for example, I'm going to show you now. Now I'm going to construct an AND gate using 2 cross 1 MUX. That is AND gate using 2 cross 1 MUX. So what do we know about AND gate? We know its block diagram, we know its logical representation, we know its truth table. Now we are going to write it down. So first, I will show you in a neat way possible. AND gate. So we know the block diagram of AND gate is 2 inputs, 1 output, A, B and Y. We know the symbol as A, B and Y, and we know its truth table A, B, Y. 0, 0, 0, 1, 1, 0, 1, 1. We know that the outputs would be 0 only for the last case. So these are the basic things we know about AND gate. Now I'm going to write for 2 cross 1 MUX. We know the block diagram same as it is. So we are having a block 2 cross 1, and here we know this is the number of inputs, this is number of outputs. So I am indicating with small letters, and we know that 2 power 1, where 1 would be the number of select lines. So down would be S and this would be the Y. And there is, you can't say there is a logical representation for a 2 cross 1 MUX, like a logical symbol for 2 cross 1 MUX, because a logical, the Boolean expression would be a big one and there would be a big diagram. So in place of this logical symbol, I'm directly writing the truth table or the function of 2 cross 1 MUX, S and Y. When S is 0, output is A. When S is 1, output is B. So simply to say, in a diagrammatic way, I'm going to draw here. When S is 0, output is A. That is nothing but this is A, this is B, and this is Y. So when S is 0 case, what is the S is 0? Output is A. So this line is going to connect it here. In the same way, when S is equal to 1, A, B, Y, this line would be connected to the outputs. Here we know when S is 0, output is A, and when S is 1, output is B. So now we are going to construct an AND gate using this 2 cross 1 MUX. So now we know in the previous minute or earlier minute, we have seen when S is equal to 0, the multiplexer would be connected like this, and when S is equal to 1, the multiplexer would be connected like this. We have seen this earlier, and we know the truth table of AND gate A, B, Y. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. And we also know the basic function of the 2 cross 1 MUX or truth table of 2 cross 1 MUX. I would write here. So S and Y. When S is 0, A. When S is 1, B. Now we know that AND gate is having 2 inputs. Yes. And another thing we know that, 2 cross 1 MUX is also having two inputs, but it is having a select line. Now we have to convert this into a two input line. I mean, where there are three inputs, now we are going to convert this like two input device. How we are going to convert it? We have seen in this table the functionality or the output mainly depends upon the select line. Yes, that means in these two inputs, one must be select line. That is, for example, I am showing you, if we are constructing an AND gate using this 2x1 MUX, one input must be the select line, and other input may be your A, maybe your B. I am considering this A as the input line. Okay, yeah. So yes, from here S, and I'm taking A and then taking Y. Now 0 0 0 1 1 0 1 1. We have seen here, we know that AND gate functionality, all are 0 and the last case would be the 1. We know this is the function of AND gate. When you clearly observe here, when S is 0, output is 0. Yes, that implies when S is equal to 0, implies Y is also 0. Yes, and when S is 1, output is same as A. That is, when S is 1, A is 0, output is 0. When S is 1, A is 1, Y is also 1. That is A value. That means when S is equal to 1, Y is equal to A. So now based on these values, I am going to make a small changes for the 2x1 MUX block diagram. 2x1 MUX. Okay. So when S is 0, you can take this S. Output is also 0. This is Y. That is, I have told you in the earlier, in previous minute, I have shown you in the diagram, when S is equal to 0, A line is connected to Y. Yes, hence this would be ground. That is nothing but when S is 0, output is 0. 0 is nothing but ground. And when S is equal to 1, I have told you earlier that this line is connected. There is nothing but B is the output for Y. But here B is A and A is 0. That is, this is A and this is B. But this B is A. So in this way, we have constructed an AND gate using 2x1 MUX. If you are not clear with this one, I am going to tell you again. So from this table, we have seen that when S is 0, Y is 0 anyways. So when S is 0, Y is 0. When S is 1, Y follows the values of A. That is, when S is 1, Y is 0. That is, A is also 0, Y is also 0. When S is 1, A is 1, Y is also 1. So now I am taking here 0 and A as A and B for 2x1 MUX. That is, this A and B are inputs for 2x1 MUX, where this capital A and capital B are, you can say, inputs of AND gate. So now I have just replaced this A and B with the values 0 and A. But here I have represented 0 as ground and represented this second terminal as A. This is nothing but the construction of AND gate using 2x1 MUX. Thank you.